Hello and welcome to Mysteries of Science. My name's Kieran, and as you might know if you've listened to the podcast before, I'm part of the team behind Science+Nature, which is the monthly magazine from the people who also make The Week Junior.
And I'm Stevie. Today we're going to go for a rummage in our inbox to find out which mysteries you want us to solve. And then, with the help of some extra special guests, we're going to crack those cases.
Each of these mysteries that we're going to talk about today was suggested to us by email or in a review on Apple Podcasts. So if you feel inspired while you're listening to this episode, just drop an email to hello@science-nature.co.uk with your ideas for a future mystery.
All right then, here we go. Let's get to our first mystery, which also happens to be one of the biggest mysteries of all time. This one comes from Ben, aged 8, who asks, why did the Big Bang happen? So, who can answer Ben's question?
Hello there, my name's Pete and I work for the Royal Institution, a science education charity. And my job is to organise exciting science events for young people and families. I get scientists to come and explode stuff. I do all sorts of exciting science events, but also you might have seen me in the pages of Science+Nature answering your questions in my Head Scratchers column. Yeah, so this is a fantastic question and one that's perfectly suited to this podcast because it's one of the big mysteries of science that still nobody really knows the answer to. But yeah, the best place to start is, what was the Big Bang? So this is what most scientists now accept is how our universe, as it currently is, started. So just before the Big Bang, everything that makes up the universe was in a tiny, tiny, tiny small amount of space. So thousands of times smaller than even a grain of sand. So that's everything in the universe. Universes, planets, stars, galaxies, all of it less than a grain of sand. And then suddenly this expanded outwards, a huge explosion of energy. And then as it slowly expanded outwards, everything started to cool down. And then from that murky soup of everything, slowly galaxies, planets, everything that we actually know as the universe started to form. So that's what the Big Bang was. This going from a tiny, tiny, tiny ball of everything, expanding out, cooling down, becoming the stuff that we know is our universe today.
So while new technology means scientists can look into deep space and discover what happened in the time following the Big Bang, it's impossible to know exactly what happened before it.
We just don't really have the scientific understanding to work out what it would have been like at that very beginning of the Big Bang. And if we can't work out what it was like at the beginning of the Big Bang, then there's no way we can work out why the Big Bang happened. Or even, here's an even bigger question, what was it like before the Big Bang? Like, stuff doesn't just come from nowhere. All of this matter had to come from somewhere. So, yeah, an even bigger question, why did the Big Bang happen? What was the universe like before the Big Bang? Was there another universe that crushed back into this Big Bang and then exploded back outwards? These are kind of some of the ideas scientists talk about, but basically, no one really knows.
I love it. Our first mystery of the episode, and it's unsolvable. It's exactly the sort of thing that I like to have on this podcast. Thank you very much, Pete, for your explanation of the Big Bang, and also to Ben for your question. We'll move on to our second question, equally brilliant, which comes from Izzy, who asks, are unicorns real? Who's going to answer this one?
Oh, hi, I'm Molly Oldfield. I'm the host of a weekly podcast called Everything Under the Sun, and children send in their questions, and each week I answer 2 of them, and each week I ask an expert to answer the third. And for this one I thought, well, there's all these different facts about what unicorns mean and stories about what they could have evolved from and stuff, but I thought it would be quite interesting to have a philosopher's take on it. So I asked a professor of philosophy at Oxford University called Ofra Magidor to answer it, and she had this to say. She said, one way to understand your question is whether unicorns exist in the same way that other animals exist. In other words, among the animals in the world, do we have, in addition to cats, dogs, horses, etc., unicorns? That's a question for a zoologist, but as far as I know, at least so far, they have not found any animals that fit our description of unicorns. But there's an interesting question for philosophers, which is, suppose a zoologist discovers an animal that sort of fits our description of unicorns, How would we decide that the animal they found really is a unicorn? To get you thinking, here are two scenarios. Suppose zoologists discover an animal very much like what we think unicorns are. It's got a tail, a horn on its head, sparkly hair, but it is shaped like a cow, not a horse. Would we say this is a unicorn, or would we say, oh, we've just discovered unicorns look a bit different than we thought they would look. They're actually like cows rather than horses. Another scenario. We know that although horses have 4 legs, sometimes, maybe due to genetic mutations, horses are born with 3 legs or 5 legs. So what if there was a horse born of ordinary horses that happened to be born with a horn on its head? Would that be a unicorn? Or would we say it's a horse with a horn? Maybe, though, you're not asking about whether unicorns exist in the same way as ordinary animals. Philosophers distinguish between what we call concrete objects and abstract objects. Concrete objects are ordinary things that we can touch and see, like tables or horses, but they're not the only objects that exist. Suppose you have an idea. Once you have the idea, it's out there in the world. It exists. It's not something we can see or touch, but the idea exists in an abstract way. So even if unicorns don't exist as an ordinary animal, is it possible they exist because they're ideas, as abstract objects? Here things get tricky. We definitely have thoughts or ideas about unicorns. We can talk about them, write stories about them, but that doesn't mean that these thoughts and ideas are unicorns. Just like when I have a thought about a person, the thought isn't a person. The thought is an abstract object, but the thought is about a person and the person is supposed to be a concrete object, a thing we can see and touch. Many philosophers say that unicorns, if they exist, are supposed to be flesh and blood animals. If that's right, then maybe ideas about unicorns exist, but not unicorns themselves. As you can see, philosophers spend a lot more time asking questions than answering them, so I hope this helps you think more about this interesting question. So there you go, there's a random philosophical take on whether or not unicorns exist.
Very interesting answer, and not one I was expecting at all. Well, we'll come back to Molly a little later on. Next, though, it's time for Pete again. And this question came in from a listener on Apple Podcasts. They want to know, how does the human body make blood?
This is a question with an answer, which is I like mysteries, but I also like the occasional question I can actually answer. So in our blood, there's 3 main things. We've got red blood cells. These carry oxygen around your body. So when they're in your lungs, they soak up oxygen and then they travel around your body and distribute oxygen everywhere. And red blood cells make up about 40% of your blood. Then we have white blood cells. They're only about 1% of your blood, but they're super important because they help fight bacteria and viruses. And then there's also another 1% is made up of things called platelets. And these are what helps if you've been cut, these help your blood clot together and they make sure that your cuts and wounds stop bleeding. And all of these are made, this is going to surprise you, they're made inside your bones. I think most people think of your bones as just being these kind of, they're just there to keep your skeletons together, but they don't really do anything. But actually, inside your bones is bone marrow. So this is kind of like a squishy inside that's really living. And it's inside this bone marrow. There's a really special type of cell called stem cells. And stem cells are able to become lots of different types of cell. So the stem cells inside your bone marrow can become red blood cells, they can become white blood cells, or they can become platelets. So your brain will send signals to your bone marrow and it will start producing whichever type of stem cell your body needs. So maybe you've had a big infection, lots of your white blood cells have been used up, so then your body will trigger your bone marrow to start producing white blood cells. Or maybe you've bled a lot and then your body will start producing lots of red blood cells. And in fact, if kind of per peak production, your body can make 2 million new red blood cells every second. So this is a huge bit of machinery that's hidden inside your bones.
Hey, we answered one. Definitive answer to that mystery. Fantastic. There must be a lot of mysteries that are related to the human body. It's not something we've done a whole lot on before. So if you've got any ideas, make sure to send them in. We'll be giving out all the details for how to do that again at the end of this podcast.
Well, we're just over halfway through this episode's mysteries, so it's back to Molly for a different kind of space mystery. Why is Pluto no longer a planet?
Oh, this is an interesting one. So it was discovered in 1930 by an American astronomer called Clyde Tombaugh. He was at an observatory in Arizona. He discovered it and got really excited, and everyone thought it was a new planet. But then astronomers began to think, oh, actually, there's lots of other icy bodies around it, and maybe it's part of a group of these icy bodies which are just beyond Neptune. So then they all started saying, ooh, maybe all these icy bodies should be called planets, so we'll have loads more planets. But then they all started trying to work out what actually is a planet, and there wasn't an official sort of list of what you had to do to be a planet. So in 2006, the International Astronomical Union decided to work out this list and say, here are the things you have to have if you want to be a planet. They decided that you have to be 1, in orbit around the sun, 2, to be almost round shape, and 3, you need to have cleared your neighbourhood, which is a bit strange, but what that means is that there aren't any other big things other than the planet's satellites close to it in space. And Pluto didn't fit this third criteria because it shares space with all these other icy bodies that they were looking at before. So they decided Pluto can't be a planet, and so now it's called a dwarf planet. And lots of scientists actually think this was not a good decision, and they say that only 5% of the world's 10,000 astronomers took part in the vote. But for now, Pluto is a dwarf planet, but I don't know, in the future that might change. What I like about Pluto is that it was named by an 11-year-old girl called Venetia Burney who lived in Oxford. She was having breakfast with her grandpa, and he was reading a newspaper article saying, oh, we found this new planet, but it doesn't have a name. And she said, why I think it should be called Pluto, because she was learning about Greek and Roman gods and she liked the name Pluto. And her grandpa thought, oh, well, this is a good idea. And he had lots of very influential friends at Oxford who he went and dropped letters into, and they passed it on to the observatory in Arizona who'd found the planet, and they loved the name and decided to call it Pluto. And as a present, her grandpa gave her £5, which was a big reward at the time. And and it used to be said that she named it after Pluto, the cartoon dog, but she didn't because he was actually named after the planet later.
I think it is high time that Pluto gets reinstated as an official planet for no reason other than it was an official planet when I grew up, and I will not rest until it is recognised as such again. Anyway, moving on to the final mystery of today's episode, which is another really big one.
I'm Logan. I'm 8. I'd like to know what's inside a black hole.
Pete, what can you tell us?
Yeah, so again, knocking it out of the park with the real nobody really knows question. So black holes are regions in space that have a really, really high mass. So mass being weight, so lots and lots of matter. And they're so heavy that their gravity is really, really strong that they even pull in light. So this is why we call them black holes, because we can't see them because they suck in all of the light. So we can see the sun in the sky because it's burning hydrogen and blasting rays of light out to us. But because black holes are so massive, their gravity pulls in light, we can't see them. So that's why we call them a black hole. But we only know they exist because weird things happen nearby. So stuff gets sucked into them. They warp things around. So that's how we can see them in the sky. Perhaps my favourite scientific word relates to black holes. It's the phrase spaghettification. I don't know if you've ever heard of this. Basically, if anything comes too close to the edge of a black hole, you'll get stretched out essentially into a long strand of spaghetti. So because the strength of the gravity increases the closer you are to the black hole, if you're lying flat with your toes, imagine you're going down a slide and your toes are pointing towards the center of a black hole. at your toes, the gravity will be so much stronger than where it is at your head. That force will stretch you out and spaghettificate. Spaghettificate? Difficult word to. You will be spaghettified and kind of stretched out. And recently, a telescope saw this happening to a star. There's telescopic evidence of spaghettification. So it sounds like a silly word, but it is actually, something that black holes do.
What a great word!
So the question of what's inside a black hole, basically we don't have the science really to understand what it's like there. Again, it's another fantastic area of research. There's loads of crazy mind-bending science going on to try and understand what's going on, but basically this is another one for the readers of Science and Nature and the people listening to this podcast to go on and study in the future and work out what's really going on.
Oh, black holes are amazing, aren't they? And I think we could definitely devote an entire episode to them in the future. Thank you for the quick tour around them, Pete. And thank you all so much for your questions. Keep them coming. Remember to send in your thoughts through voice clips, videos, emails, and podcast reviews. You can get in touch with us by emailing hello@science-nature.co.uk. And your reviews can go on Apple Podcasts or wherever you listen.
So this is actually my last episode of Mysteries of Science, but the mysteries shall continue. So you'll still hear from Stevie and Dan, and Michael from the Week Junior Show podcast is joining the team as well. It has been so much fun investigating more than 20 different mysteries on the podcast. And I want to thank everyone for listening, getting involved, sending in their ideas and their questions.
And I want to thank Kieran because he's been so amazing and we're going to miss him so much. This is also the last episode of Season 2 of Mysteries of Science, but we'll be back before long. And remember, you can always go back and listen to old episodes wherever you are listening to this.
Yes, and if you're ever in desperate need for some more Mysteries of Science, make sure to pick up the latest copy of Science and Nature.
Until next time,
stay curious.
If you want to get your hands on a copy of the Week Junior magazine, we're offering a 6-week free trial. To get yours, head over to dennismags.co.uk /The Week Junior and use the code PODCAST.